Okay, in this video, we're just going to look at the general definition and notion of inverse functions. So let's first recall that we can have the model of a function as a machine which takes an input and gives you an output. So for example, here, if x was the input to the function f, then we designate f of x as the output. And sometimes it makes sense to take that output and feed it into a second function. So here I'm taking the output f of x and putting it into a second function g. And so, of course, our output would then be g of f of x. Now, what may happen sometimes is g might undo whatever f did to the original input. So the question would be, is this output ultimately, did it get us back to x? If so, I'd say g undid whatever f did to x originally. And if so, if g of f of x is x, and if it goes the other way, if you could switch the rules around and f of g of x was x, for all x on their domains, for all x for which this would make sense, then we're going to say that g and f are inverses of one another. And we have a notation. Instead of g, we'll just write f to the power minus 1 to designate the inverse of f, or the g to the minus 1 to designate the inverse of g. That does not mean, by the way, 1 over f or 1 over g. It's just a functional notation. Now, some functions don't have inverses. For a function to have an inverse to begin with, it has to be 1-to-1, or graphically pass the horizontal line test. I'll comment on this in a few moments, but let's just look at an example of what we really mean by inverse functions. So if you look at the function f of x equal x cubed plus 10, then I claim its inverse is the function, the cube root of x minus 10. So let's check this out. Let's look in both directions. Do these really undo one another? So first of all, f of f inverse, let's take a look at that. So I'm plugging, think of it this way. I took an x and I fed it to f inverse, and I get this output. Now I'm going to take that output and put it as an input to f. Now what does f do? To anything you give it, it cubes it and then finishes by adding 10. So let's do that. We're taking the input to f, cubing it, then finish with adding 10. But the cube of a cube root gives you the thing under the cube root, namely x minus 10. Then when we add 10, we see we do get x back. How about the other direction? What about f inverse of f of x? So I take x, give it to f, and I'm sitting here at x cubed plus 10. Now I'm going to take that and feed it into f inverse here. So notice this gets right there. So I do what f inverse says to do. I first subtract 10 from the thing you gave it, then take the cube root of all of that. Now notice under here, under the cube root, the 10 minus 10 is 0. So I just get that it's the cube root of x cubed, and again giving me x. So we have checked that these two functions, namely x cubed plus 10 and the cube root of x minus 10, are inverse functions. Now, what about this 1-to-1 business? Why must a function be 1-to-1 or pass the horizontal line test? So let's just take a classic example. Let's look at the function f of x equal x squared. Notice that f of 2 and f of minus 2 are the same thing, 4. So let's just suppose we had an inverse here of the square function. I know what you're thinking. There is one, right? Well, let's see. So think of this just schematically. I could take either minus 2 or 2, give it to the square function, but they both give me the output 4. Now suppose I wanted to try to undo that, right? I want to send 4 back to where it came from. Where do I send it? I have a choice, and that means really that doesn't define a function. A function to each input should have only one output, not two. Well, okay, we can recover this, but we have to be a little smart about it. We have to say, hey, our original function x squared, let's restrict its domain to just the non-negative numbers. And now it does pass the horizontal line test very easily. And we even have a name for its inverse now, right? We have the square root function. So the square root of 4 is 2. And in particular, the square root of anything is always the non-negative version, which you would square to get x. Okay, so there's inverse functions.